So this is another practice problem or example problem for product of inertia. I chose it because the different sub areas illustrate different signs because the shapes are at different orientations, plus the dx's and dy's are positive and negative. And also there's a hole, so there's a negative hole. And so it illustrates all the signs that you have to keep track of when you're working a product of inertia problem. And again, this looks weird. This is a cooked up problem. So we basically have a basic rectangle that's slightly off from the axis. The centroid of this rectangle is 1 centimeter to the left of the origin. There's a right triangle here. There's a right triangle here. There's a quarter circle, and there's a circular hole. So there's 1, 2, 3, 4, 5 shapes. And again, I chose these again for different signs. And so keep in mind, I bar xy, the centroidal IXY for each sub shape can be 0, positive, or negative. And that's true of several of these. dx and dy can be positive or negative. And that's true of several of these. And finally, a hole is subtracted. The entire term is subtracted. We don't use a negative area for a hole. We subtract the entire term for the hole. That's how we handle a hole. So each of these terms is going to have positive and negative signs depending on the case. So just pay attention. That's why I chose this problem. So first of all, for the rectangle, his I bar is 0 because he's a rectangle. His area is 10 times 2. His dx, which is the distance from the y-axis to his centroid, is minus 1 centimeter. And his dy is 0. And so that entire term is 0 for the rectangle. For our triangle at this orientation, the large triangle up here, a triangle at that orientation has a positive number or positive sign. And so it's positive 1 over 72 b squared h squared. And so it's positive b squared h squared. His area is 1/2 base times height. His dx, his centroid is 2 over from y, so his dx is negative 2. His dy is 1 plus 1, so his dy is plus 2. So minus 2 plus 2. So minus 2 plus 2 for the triangle. For our other triangle, for this guy down here, a triangle at this orientation has a negative sign, 1 over 72 b squared h squared. And so negative 1 over 72 b squared h squared, 3 squared times 2 squared, 3 times 2 squared. His area is 1/2 base times height. His dx is minus 4. So when you go from the y-axis to his centroid, it's 3 plus 1, which is minus 4, is his dx. His dy is minus 1 plus 2/3, which is 1/3 of 2. And so 1.667 negative. So negative 1.67 is his dy. For the quarter circle, he's at this orientation here. So a quarter circle at that orientation is going to be a negative sign at this orientation, negative 0.01647, negative r to the 4th. His area is pi r squared over 4. His dx is 2 plus, so 4r over 3 pi for him is 0.8488. So his dx is 2 plus that, so it's 2.488. and his dy is 1 plus that, which is 1.8488, and they're both positive. So positive dx and a positive dy. Finally, there's a hole. So we subtract off the hole. He's a circle, so his I bar xy is 0. His area is pi r squared, so pi times 1 squared. His dx is minus 2. His dy is plus 1. So minus for the term, 0 for the I bar, area, dx is minus 2, dy is plus 1. So again, I chose this example on purpose for you to stretch your muscles on identifying the orientation of the triangles, the orientation of the quarter circles, the positive and negative dx's and dy's, and to be able to subtract off a hole. So a lot going on, but these are the skills that you need to find product of inertia for composite areas made up of all of these different kinds of subshapes. I hope this helps.